So we are going to do network analysis. Okay. So in the beginning, we'll start with a simple problem using basics law. Okay. And as we move, we'll take complex and complex circuits. So network analysis. Okay. So the first law is Ohm's law. Okay. So if you have a resistance R, okay, and you're applying a voltage source V, so a current will flow in the resistance I, okay, and that current, the relation between this V and I is given by V equals to IR. As you increase the voltage, current will also increase. So if I measure the voltage here, if I put a voltmeter here, okay, if I put a voltmeter here, digital voltmeter, okay, or any voltmeter, okay, so it will give me the positive value, okay. So this V will be equals to IR, it will be positive value. That is your Ohm's law, okay. Say this is 0. I'm putting a digital multimeter. Now same question. This is the voltmeter positive, voltmeter negative, okay. Now in the same resistance, okay, current flowing in this direction, okay. I am applying a voltmeter, the current is flowing like this, and I am measuring voltage like this, okay. That means now my voltmeter is like this, okay. This is 0, this is a positive, positive, this is a negative, okay. So in this case, my voltmeter will show like this, voltage will show like this, okay. That means now this is my I flowing here. So now if I measure this V voltage drop across the resistance, okay, voltage, this is the battery, okay, and you say this is VR, so say this is a voltage drop across this one, VR. Then VR will be your not IR, it will be minus IR, okay. So what I'm trying to say, this is the whenever you measure voltage in the direction of current, okay, if current is flowing like this will be your higher potential and this will be your lower potential, okay. So voltage difference will be positive, higher to lower, higher minus lower will be positive. So voltage difference VR will be positive, okay. Now same resistance, okay, current is flowing this direction, but you are measuring voltage like this, okay. Now because current is moving in this one, this is your higher potential and this is your lower potential, but you're trying to measure the voltage here, this minus this, so this will come negative. Voltmeter will show negative values, okay. So actually drop is here to here, okay, but you're putting the voltmeter in opposite side. That convention you should always remember how you are measuring the voltage. If you're measuring the voltage in the direction of the current, then no issue, you get positive sign. But if you are opposed, you are tilting your or changing the polarities, okay, then you have to put the minus sign whenever you want to write the drop. Is that clear? So this is your basic Ohm's law, V equal to IR, and so this is sign convention you always remember, okay? If you are measuring the voltage drop across and in the direction of the current, then it will be positive. If you are measuring the voltage drop across the resistance opposite to the current, then it will be your minus IR. The sign convention you should always remember. So this will be clear with example. Now, let us say the next basic law is Kirchhoff's current law. Kirchhoff's current law. Okay, so Kirchhoff current law says algebraic sum of currents at any node is zero. Sum of all the currents coming to any node is zero. Okay, so suppose this is my node A, and some currents are coming and some currents are leaving. I1 current is coming, I2 current is coming, I3 is leaving, I4 is leaving. Okay, so algebraic sum of currents. Okay, so some currents are coming and some are leaving. So there is a charge conservation because the amount of currents coming, the same amount of currents leaving, they should be equal, because here at the node there is no accumulation of charge. Okay, so this is a basically conservation of charge, representation of conservation of charge. This law says charge is conserved because no charge is stopping here, no charge is accumulating while current is moving at any node. So the current which is coming towards the node, they should go away. Okay, so while writing this law, you have to remember, you have to put a sign with current with a sign. Okay, so generally it is your choice whether you want to take incoming current positive and outgoing current negative, or you can take incoming current negative and outgoing current positive. That is your choice. Okay, that will not affect your analysis. So generally I take outgoing current positives. Okay, but you can take anything. So that is a choice. You decide first. Whenever you want to apply this law, you have to decide that what you are going to take. Okay, so for example, if I say incoming current is positive, so I can write I1 plus I2 because these will be positive incoming currents. Okay, so incoming currents are what? Incoming currents are I1 and I2. Okay, so both will take positive, and outgoing currents are I3 and I4, that you have to take negative, minus I3 minus I4 equals to 0. So algebraic sum of the current at any node should be 0. Okay, and if I say I1 plus I2 equals to I3 plus I4, that is incoming current equal to outgoing current. Incoming currents is equal to outgoing current is not, charge not accumulating. Okay, no accumulation of charge, accumulation of charge, no accumulation of charge. So current should be equal. Okay, let us understand this with an example. So shall I erase this one?
Yes, sir.
Okay, so suppose you have a resistance, a 5 ohm resistance, and this is your 10 ohm resistance. Okay, and here I'm applying plus minus 10 volt. Okay, so say I current is coming. Okay, how many nodes are there in the circuit? Tell me, how many nodes are there in the circuit? Two. Okay, so this is a single node, and this is not two nodes. Two nodes are there. Okay, so now you have to apply Kirchhoff. This question can be solved very easily with Kirchhoff current law. Okay, so the question is find I1 and I2. Okay, so tell me, what is the value of I1? Can anyone tell me what is the value of I1? What is the value of I1? Directly just look at the circuit and tell me what is the value of I1.
2, sir.
2. Very good. Okay. Because you see, you know Ohm's law. Okay. So I will use only those things which you have learned. Okay. But here, so if it is these resistors are parallel. Okay. So if this is the 10 volt, obviously this is the here is also 10 volt. 10 volt here also 10 volt because they are all parallel. 10 volts. Okay. So that means now current I1 will be what? I1 will be is total voltage, Ohm's law, total voltage. If you know the total voltage and total resistance, you can find the current. Okay, that's 10 divided by 5. This is your 2 ampere. Similarly, if I say my I2 is what? I2 is your again 10 volt divided by 10, 10 volt, 10 in 10 ohm. So this is your 1 ampere. Okay. So what is I? How much is I?
I1 plus I2.
I2. But this is a node. Okay. And the current Kirchhoff current law says that algebraic sum of current should be 0. Okay. So if you say incoming current positive, outgoing current, these are out. You say incoming current towards the node A, it is a node A. I outgoing is I2, I1 is outgoing out. This is also outgoing. I minus I1 minus I2 equals to 0. So I will be your, so apply KCL at node A. Okay, this is node. So this will give you I1 plus I2, and this will be 2 plus 1. So I will be your 3 ampere. Okay, let us do one more problem. So I'm erasing this one. You can stop me if you are not written. Okay, let me say I have one more circuit here. 10 volt. This is R2. Okay, say this is R1. Say this is R3. And say this is 5 ampere. Okay. And the question it is given that this current is 3 ampere. This current is 3 ampere. And they're asking me R1, R2. Okay. And say this current is 2 ampere. You tell me how much current is flowing in the resistance R3. Tell me. Calculate current I. Question is find current I. So first you have to find nodes. How many nodes are there? This is node A. This complete is one node, and this complete is one node. Okay. So KCL will be applied at which node? If I say this node is B, and this is say C. So at which node you will apply KCL? Tell me.
B node पर sir.
B node पे. Okay. So apply KCL at node B. We apply KCL at node B. Okay. So how much current is incoming current? Incoming current is what? Incoming current 3 ampere. Outgoing current 2 ampere plus I, and incoming current is what? 3 ampere and 5 ampere, because it is a current source. So this will give you 5 ampere current. So incoming currents are 3 ampere and 5 ampere. Outgoing currents are 2 ampere and I ampere. Okay. So you can write the conservation law, incoming current is equal to outgoing current. So this will be 2 plus I equals to 3 plus 5. So I will be your 8 minus 2, 6 ampere. Okay. So this way you can apply KCL. Let me put one more question. So first we are doing simpler circuits, okay, so that the basic laws should be clear. And say you have this plus minus 18 volt, then you have a resistance RA, then you have a resistance 6 ohm. Say this current is 8 ampere given in the question. This is your resistance. This is the voltage source Vx. This is a 5 ohm resistance, and the current is given 13 ampere. Okay, that means this here in this branch current is 13 ampere. So you have to find how much current is flowing 6 ohm. Okay, how much current is flowing in RA. Okay, so then find IX. Okay, IX, IA, and RA. Find out. So again, can you tell me what is the value of IX? What is the value of IX? So the first of all, you see this is the node. Okay, we are we're coming here, and this current is coming from here. Okay, 8 ampere. So incoming current. So say this is node A. Okay, so 8 node A. You can say 8 ampere current is coming. Okay, and then this node 13 ampere also current is coming towards this node, and the leaving currents are what? IA plus IX. Okay, can you tell me what is IX? IX का वैल्यू कितना होगा? Just look the circuit, simple है. रिचा
Yes, sir.
कितना होगा? IX सामने देखो सर्किट में, जोशीबा, करिश्मा. ये 6 ओम क्या है, किसके पैरेलल है 6 ओम? This 6 ohm parallel to this voltage or this voltage? So
VX,
if,
sir.
so if you see this is the
Sir,
parallel,
VX.
this parallel, so this is the parallel to 18 volt, not Vx. How it is
3 ampere हो
parallel to?
जाएगा.
Because
How?
here the resistance is there, na? Okay.
Yes sir.
So this end-to-end connection is with 18 volt.
तो 3 ampere हो जाएगा.
So Ix will be simple. So Ix is your Ix will be 18 volt divided by 6 ohm. That will be 3 ampere. Okay. So you know the Ix now. You can find the Ia. So Ia will be what? 21 minus 3. How much? 18 ampere. Okay. So you find you have you got Ix, you got Ia. बताओ RA कितना होगा, बताओ आपकी. What is RA? रेजिस्टेंस कितना होगा RA की वैल्यू? और भी इतना नहीं सोचना है. क्या मैंने पूछा कि रेजिस्टेंस कितना होगा, तो आपको पता करना है रेजिस्टेंस कैसे निकाल सकते हैं। रेजिस्टेंस निकालने के लिए वोल्टेज निकालना पड़ेगा, करंट निकालना पड़ेगा। करंट आपको पता ही है इसके अंदर
सर
कितना है,
1 ओम आएगा।
1 ओम आएगा। तो आपको ऐसे पता ही है, जब भी ओम्स लॉ है तभी हम ये बेसिक क्वेश्चन करा रहा हूँ। ओम्स लॉ क्या है, V इक्वल टू आई आर। Out of three quantities, if you know two quantities, next other quantity you can find out. Okay, if you know total resistance, you know the total voltage value which is along this total resistance, you can find the current. Okay, similarly, if your total resistance you have a I, you can find the V. You have say R and V, you can find the I. So here you know IA is given. Okay, voltage is parallel to this one, so you can find the RA. So RA will be your 18 volt divided by 80, that is your 1 ohm. Okay, so you have to carefully look the circuit. Okay, so this is your Kirchhoff current law. Now your next is Kirchhoff voltage law. Kirchhoff's voltage law. Okay, so Kirchhoff voltage law says that algebraic sum of voltages around any closed loop, algebraic sum of voltages around any loop is 0. Okay, if you sum all the voltages in a closed loop, their sum should be 0. Okay, now you are when you're moving in a loop, okay, in circuit and loop or in a mesh, you will get the two type of voltages. Okay, either you will get the voltage rise or you get the voltage drop. Okay, there will be a source of energy, and there will be resistance where drop will come. Okay, so for example, if I am going from my battery is like this, okay, minus plus, and I am moving from minus to plus, so this is the voltage rise or voltage drop. It is the voltage rise or voltage drop if I'm moving like this.
Rise.
Voltage
Rise.
rise.
Voltage rise.
So this is a voltage rise. So only you get two type of voltages, voltage rise or voltage drop. Okay. Similarly, if you move from higher potential to lower potential, this is called voltage drop. Okay. Similarly, if you say you find a resistance and you're moving with in the direction of current, or what you here is a voltage here minus, voltage drop is like this. Okay. So this is voltage drop. Okay, and if you are moving in the resistance R, okay, current is in this direction, current is in this direction, but the voltage is mentioned like this, your measurement is measured like this, then this is called voltage rise. Okay, so you have to keep in mind how you are moving in the circuit. Okay, minus to plus will be voltage rise. Okay, and this will be a voltage drop. So you encounter these four type of voltages in a loop. Now this says algebraic sum of voltage around any loop should be 0. Okay, now again, like Kirchhoff current law में हमने क्या किया, we have taken incoming current positive, outgoing current negative, or outgoing current positive, incoming current negative. Similarly here also you can choose. Okay, you can choose voltage rise as a positive, and voltage drop as a negative. Okay, but then if you can choose this one, but when you choose this one, when you say voltage rise is positive, sign is coming negative. Okay, and voltage drop you say negative, but sign is coming positive. So this sometimes it may cause some confusion to you, so I will advise you take voltage rise as a negative and voltage drop as a positive, because now you don't have any confusion. Whatever a sign will come in front of you, you'll put that sign, okay, with magnitude, so there will be no issue. So for example, I will give an example. So to demonstrate this one, so say I have a closed loop. So this is my B1. Okay. plus minus V1, a resistance here V2, a resistance one more V3, okay, and say here one more battery minus plus say V4, and I am putting some element, one more element here, say that element is your V5. Okay, you can put anything. Some element is there where you're getting voltage drop. Now you want to apply Kirchhoff voltage law here in this loop. Okay, so how can we apply? So first of all, any loop you get, जो भी loop है, उस loop में you have to decide which direction you are moving. Either you are moving anti-clockwise or clockwise, that is your choice. Okay. For example, I'm moving like this. I say this all resistance here, I current is flowing in the circuit. Or forget the I right now. You say I am writing only voltages. So now if you apply in this loop voltage KVL, voltage Kirchhoff's voltage law. So KVL apply in this loop. So what I'll do, I'll come start with this one. This will be minus V1. Okay. अब इसमें कुछ सोचना नहीं है. You don't have to think anything. Whatever sign is there, you write with the sign. Put the sign and write the magnitude. Here plus minus. Okay. So it is plus is there. You write plus because it is a drop. Whatever sign is given in the question, you have to write that one. Okay. Plus.
Sir,
Yes. Tell me.
sir, this V2 and V3 is voltage.
Which one? This one.
Yes, sir.
Voltage drops. These are
Okay.
voltage drop, right? Resistance is there. Okay, some resistance will be there, say R1, R2. Okay, so this
Yes,
is the voltage. Okay, so this is voltage rise. So I'm taking whether there's a voltage drop or voltage rise. Okay, anything voltages are there in the voltage differences or voltage. Here, this is also voltage difference from this point to this point. Okay, so whatever voltage or voltage differences are there, you have to write. You have to move in the loop and you have to put everything with the sign. Okay, now this will be plus V3. Now you have to write V4, that will be minus V4. Okay, and then you put plus V5. Okay, now this is equal to your what? This is equal to your V1 plus V4 equals to V2 plus V3. Sorry, V1 plus V4, V2 plus V3 plus V5. Okay, now V1, V4 is what? V1, V4 is voltage rises, and these all are voltage drops. So you can write in a loop voltage rise, okay, is equals to voltages drop. Voltages drop. Basically, these two are sources, okay, and they both are in series. Okay, so they are adding. So these voltages will these are voltage source, and this total voltage will be drop in the all the circuits. So there are V2, V3 plus V5. They will be equal to your V1 plus V4. Okay, but just you have to draw and the loop and everything. Just you have to write a KVL with a sign. Then there will be no mistake in the question. Okay, let us understand with an example. So these are basics, KVL and KCL. You can apply any closed loop. Okay, so any closed loop applicable to closed loop. Loop should be closed only. Okay. Now let us say one problem is there. Say I have this plus minus 20 volt. Here I have a resistance. Okay. Say 2 ohm, 3 ohm, and this is my 5 ohm. 5 ohm resistance are there. Say this is my battery. I say this is my V1. So I say this is my V2, and I say this is my V3. Okay. So tell me what is the value of V1, V2, V3. I have to find the value of V1 plus V2 plus V3. Okay. So the question is find and say current is flowing here. Find V1, V2, and V3. Okay. So this is a single loop. Tell me.
4, 6, 10.
Yeah. So this is a single loop equation. Okay, single loop. So I don't have to think anything. Single loop is there. I'll simply apply. I'll apply KVL. Apply KVL in the loop. Apply KVL. in the loop. Okay, so what I write minus 20, I'll write plus V1, I'll write plus V2, I'll write plus V3 equals to 0. Okay, now so V1 plus V2 plus V3 equals to how much? 20. Okay, now what is V1? V1 is basically your voltage drop. I, how much current is flowing I in the circuit, I into R, that will become, so V1 will become 2I. Okay, similarly your V2 will become voltage drop with the Ohm's law, 3I, and your V3 will become your 5I. Put the value here, you get the I. Once you know the I, you can find what is V1, V2, V3. So put the value here. So this will 2, 3, 5, 10. So 10I is equals to your 20. So I is equals to 20 by 10. That is 2 ampere. Okay. Once you know this 2 ampere, I is 2 ampere. So V1 will be what? 4 volt. V2 will be your 6 volt. And this will be V3 will be your 10 volt. You can easily find. Okay, so this is a single loop equation. There can be more than one loop also. So up to here is very simple. Everything is clear to you now.
Yes, sir. Clear है.
So this is a voltage and this is the voltage drop. Okay, now let me put this sign opposite. Okay, so current is if current is flowing like this, so say now this is minus, this is plus. So when I put the sign, that doesn't mean this is the actual sign. This is how I am measuring. Are you getting? The voltage, if I measure V3 minus V1, that is coming to positive to me, 10 volts. When I'm measuring with the voltmeter is same sign, has the same polarity in the direction. Now if I measure a voltmeter opposite, okay, if I say I'm measuring opposite, I'm measuring like this. Tell me what is V3 now? V3 कितना आएगा बताओ? Again find V1, V2, V3. V3 कितना आएगा बताओ? अभी कितना आया था? 10 आया था. अभी कितना आएगा? minus 10 ही आएगा और क्या आएगा? जब if you are measuring it this 10, you may minus 10. Let us apply KVL. So I'm changing the sign so that we should demonstrate how to apply Kirchhoff law. This is simple circuit, so you are applying it easily. Okay, so always you have to keep the sign. So apply, say current is moving like this, apply KVL. Okay, so apply KVL. Now it will become minus 20 plus V1 plus V2, this will become minus V3 equals to 0. So V1 plus V2 minus V3 equal to 20. Okay, but now what is V1? V1 is your IR, 2I. V2 is again your 3I. What is V3? What is V3?
Minus 5I.
Minus 5I. That is Ohm's law. I told you, if your current is moving like this, you are measuring like this, that is V equals to IR. But if you are measuring opposite, if you're measuring current is going like this and you are measuring the voltage here, V, then this V will be minus
Minus
IR. Okay, so this is
5I.
minus 5I. Okay, now
Yes, sir.
so again you got this thing. Now put the values here and find the I again. So I will come same, because again this minus will become answer to I is same na. Whether you are measuring like this or like this, that will not affect your current. Actual current is what is flowing. Okay, so only you are measuring in the opposite way. So this will become 2, 3, 5, 10. Again 10 I is equal to 20. I is equal to 2 ampere. Put the value. V1 will be again 4 volt. V2 will be your 6 volt, and V3 this time will be minus 10 volt. Okay, so that thing
Sir?
you have to keep. Yes, tell me.
Sir, isn't V3 voltage rise?
Hi, so and voltage rise is equal to minus. So when voltage rise is negative, it becomes voltage
So
drop.
voltage we can take the voltages rise to one side of the equation, sir.
Yes,
20 plus V3.
yes, that's also you can do. You can do. So if you, so you can keep this V20 plus V3 on one side. And the thing is same, no? You can keep here. What
Then
is
minus and minus won't be plus.
no? See this is so you have to take always with sign. Voltage rise with sign. Okay.
Okay, sir.
With sign you take na. So I would take sign with sign only. If you can take 20 with sign also. You say this is sign.
Okay, sir.
Either you write, you say minus 20, minus V1, plus V1, plus V2, minus V3. So I'm putting this both as sign with sign. They'll go either here. So now you don't have to think anything. You just have to put sign and you have to take the value. That's it. So I'm giving you one more question. Say, just give me 1 minute. So let me draw some circuits. So this is, say, I have a battery 10 volt. This voltage is V1 and this voltage is 8 volt. Okay, so polarity you can take plus. This is 8 volt, and here you have a V2, and you are putting here one more resistance. The resistance value you don't know. Okay, you know the voltage is 2 volt. 2 volt drop is there. Okay, say R1, R2, you don't know. Okay, so find V1 and V2. Tell me, what is V1, V2? So first thing, now there's a two loop, okay, and you have to move. So, but there is a law is in every loop, sum of voltage should be 0. So obviously this is the battery which is giving source voltage. Drop is here and here. Okay, so you know 10 volt is battery, 8 volt drop is here. Remaining will be what here? 2 volt will be here. This voltage. So there are 3 voltages in a loop. Okay, 2 are known, 10 and 8. Remaining will be what? 10 minus 8, 2. Okay, so you how to you so say this is loop 1, this is loop 2. Okay, so apply
2 और 6 आ रहा है
KVL in loop 1. Okay, so this will be minus 10. You don't have to think anything. This is a minus 10. This is your, this is a plus is there, the plus V1. This plus is there, plus 8 volt. So you can add plus 8 volt. Okay, equals to sum of voltage should be 0. So your V1 is equals to 2 volt. 10 up to 10, 8 is there, 2 is here. Okay, similarly apply KVL in loop 2. Apply KVL in loop 2. Okay, now here you're moving like this. You can move like this also, but we are moving like this. Okay, this is minus 8 plus V2 plus 2 volt equals to 0. So V2 कितना हो जाएगा? 8 minus 2, 6 volt. Okay, so like this you can find the voltages in a loop. Let me write one more question that you have to tell me what is the answer. Shall I raise this one?
Yes, sir.
Okay.
Yes, sir.
Now say I'm giving you one more circuit. This is minus 10 volt. Okay, and here you have 100 ohm resistance. Then you have a 100 ohm resistance here, and then you have a minus 10-volt battery here. Okay. So can you find say this current is, say this I1, say this current is I2, say this current is coming I, okay. So and say this voltage is, say V1, V2. This voltage is V2 and this voltage is V1. The question is find V1, V2, I1 and I2. Fine. So what is the value of V1? What is the value of V1? So there are two loops. So how many voltages are in this loop? Only two voltages are there in the loop. Okay. So I can write minus 10 and plus V1 equals to 0. So V1 is equals to 10 volt. Already they are parallel. So V1 should be 10 volt only. Okay. So now you know the V1. Okay. Now come to this loop 1. Now come to the loop 2. What you can write? You can write minus V1 plus V2 and this is minus 10, again 0. Okay, you're moving like this. Minus 10, this value you already know. How much is this value? Tell me. Minus 10 plus V2 minus 10 equals to 0. So V2 become how much? 20 volt. Now tell me what is the value of I1? What is the value of I1?
1/10 ampere.
Okay, so I1 is the current here. You know the voltage V1, use the resistance. So voltage is your 10 volt, resistance is your 100. That is 1/10 ampere, 0.1 ampere. You can write this as 100 milliampere. I2, I2 is your
0.4 ampere. V
20
by R.
upon 20 upon 100. Okay, 2/10, 1/5. That is how much ampere? 0.2. 0.2
Yes,
ampere.
yes, sir. 0.2
That is
ampere.
200 milliampere or 0.2. Okay. So I will be what? I will be your I1 plus I2. Now
300 milliampere.
this node you can apply KCL. Okay. So this is KVL. We are applying KVL. Here we are applying KVL. And here we are applying KCL. So I1 will I2. That is 200 plus 200. Total is 300 milliampere is I. Like that you can find. Okay. So last question, last one more question on KVL, then we will move to the next things. Okay. These are simple things, but still I'm doing. Okay, because the laws should be clear. Most of the students will be knowing, but some students still may have still confusion. They can go. That's why I'm moving very slowly. Okay, very elementary circuits I'm solving here. Say you have plus minus 10 volt or to say 20 volts. Okay, 20 volts, and you have a resistance here, say 25 ohm, and then you have a 15 ohm. And then you have a 40 and 10, 40 ohm, and then you have a 10 ohm. Okay, so this point is A, this point is B. Okay, so can you tell me what is the value of VAB, that is VA minus VB? Can you find what is VA minus VB? Okay. So you can, if you don't understand, you can put the name here. This is P, Q, this is R, S, S. Now, again, you can see in this loop, okay, or you can say this whole voltage is parallel to this one. This whole voltage is parallel to this one. They are parallel. Okay. So this voltage is, so this whole chain combination is attached here. This combination is also attached here. So this voltage will drop here. This voltage will drop here. Okay. So here also voltage is 20 volts PQ, and RS voltage PQ is 20 volts. And similarly, you have voltage VRS is also 20 volts. Okay. So you can find the current here. How much current is flowing here? I1, I2. See, this is I. Okay. So your I1 will be what? Your I1 will be how much? Tell me. I1 20 divided by 40. 40, that is 1 by 2, that is 0.5 ampere. Okay. Similarly, your I2 will be what? I2 will be your, tell me, 20 upon 50, that is 2 upon 5 ampere. Okay. Now, if I say here voltage drop, how much voltage drop is here? You want to measure voltage drop here. This voltage minus is always 0. Okay. So basically, you want VA minus VB, so you want VA and VB. Okay. So current I is flowing here. So in 25 ohm. So what will be this voltage? 25 into 0.5, 12.5 ohm, 12.5 volts. Okay. So out of 20, 12.5 volt will be lost here. Remaining 7.5 will be here. You can understand in this way, or you can say what is this voltage of point A with respect to 0. You can simply write VA. VA is your resistance is 15 ohm, current is flowing 0.5 ohm, that is 7.5 volt. So this total 20 volt is getting dropped here and here. Here is 12.5, remaining 7.5 here. So this VA is 7.5. 20 minus 12.5, remaining how much here? This point 7.5. Similarly, you can find VB. VB will be how much? So VB will be 10, 40. So yes, total is 20. When I say this is 20, so this is 20 volt. Okay, directly connected to 20 volts. This is 20, this is 20, this is 20. Here voltage is 20. Here voltage is plus 20. Out of that 20, now drop is 40 into 2 by 5. How much? 40 into 2 by 5, that is 16 volt. So 16 volt getting drop here, remaining 4 volt come here. Or you can directly calculate resistance is there 10 upon 2 by 5, 5 by 2, this 4 volt. So your VAB will be how much? 20, VAB will be how much? 7.5 minus 4. How much? Tell me. कितना होगा?
3.5.
3.5 volt. Okay. There is a, let me give you one more question. So I am purposefully going slow, okay, because this network analysis is very important. Okay. So this 10 classes you have to be patient. Okay. Once you learn this network analysis, as I told you yesterday, the remaining course will be very simple to you. Okay. So say you have plus minus 60 volt. This is your 8 ohm. Now you have learned. Now you have to tell me what is the answer. Okay. I will not solve. Vx. Okay. Say this is Vx. And say this is a current source Ix. When I say current source, Ix is there, but like which the branch it's this source is present in that in that branch, it will force to current ix current to flow. Okay, that is the meaning of the source. So this is your Vx, say this is 2 ohm, this is 4 ohm, and this is 10 ohm, and this is 8 ohm, and 5 ampere current is flowing here. Okay, so find Vx. What is the value of Vx? Tell me. What is the value of Vx? So this is 60 volt. This is how much? This is how much volt? Tell me. This is how much volt? 5
40 volt.
40 volts. So remaining here how much volt is
20
present?
volt. 20 volt.
20 volts very easily. So this, you say this is voltage across V10 ohm. Okay, or you apply KCL. So minus 60. Here voltage drop across 8 ohm. This is minus 60. V across 8 ohm plus V. The sign is plus. Current is flowing. Okay, you can, sign is plotted and you can choose your sign. Okay, and you always put go from higher potential to lower potential. Then you have V10 ohm. Okay, equals to 0. So obviously minus 60 V8 ohm is how much? 5 ampere into current is 8 plus V10 ohm equals to 0. So your V10 ohm will be how much? 60 minus 40, that is 20 volt. Okay, so how much current is flowing in V8 ohm? Okay, say this current is I10. I will call this I10. How much current is flowing I10 ohm? So I10 ohm current flowing how much? 20 volt divided by 10, 20 volt divided by 10, that is moving 2 ampere. So how much current is flowing here in 4 ohm?
3 ampere.
5. 5 is coming, this 5 is coming here, this point. 2 is going down. 2 is going down. So 5 minus 2, 3 is coming here. So here current is coming 3 ampere. So I5 is 5 minus 2, 3 ampere. Okay, now this voltage is how much? 20. This is 60. In a loop, अगर 3 voltages हैं, 2 known है, तो 1 you can find. It is a loop. 60 known, this voltage known, this voltage known, automatically you can find this voltage. Okay, because sum of voltage should be 0. Similarly, now you know this voltages, this voltage, you know this current, so you know this voltage also, so you can find this voltages, this voltage. Yes or no? Tell me what is Vx now. So in this, if I move in this loop, I am moving minus V10 ohm plus this voltage, you can say something V4 ohm, say V4 ohm, and this is equal to your plus minus Vx equals to 0, minus V10 is minus 20, 4 is, you know, 4 into 3 ampere plus Vx equals to 0. So your Vx will be 20 minus 12, 8 volt. Tell me, is that clear or not?
Yes, sir, clear. ATR.
Now exactly same question I'm giving you. Okay. Now everyone has to tell me what is
सर इसमें IX का क्या रोल है? IX का
आई, इसका कोई रोल नहीं है, ऐसे लगा
ऐसे
रखा
दिया
है।
गया क्या?
हाँ, हम जो पूछा है हम निकालेंगे हम लोग।
यस सर, यस.
Okay. So I'm erasing this one. Okay. So I am giving you one more circuit and I'll give you time. You have to tell me the answer, okay? So this is, otherwise if you don't tell, this will be your homework. This is plus minus 30 वोल्ट, okay? क्योंकि अभी मैं आसान कर रहा हूँ, फिर उसके बाद में अगर अभी रिस्पॉन्स नहीं करोगे तो समझा जाएगा कि आपने समझ लिया है, फिर आगे मैं क्वेश्चन को कॉम्प्लिकेट करता जाऊंगा, ठीक है? So this is 8 ohm, okay, this is 10 ohm, and say this is 2 ampere current flowing here, exactly same question I'm giving, and this is your 2 ohm here, okay, and here also you have a 2 ohm. Again here a current is flowing Ix, so both are parallel, so here is Vx, so automatic here also Vx, okay, find Vx, find, निकालो Vx कितना आ रहा है in this circuit, exactly same question, only the values have changed. Take 5-minute time and solve.
Ten point four.
Vx 10.4. Again check.
So 12.8.
12.8 आएगा, वेरी गुड. बाकी किसी का आ रहा है? निशांत
Yes, sir.
आ रहा है ना सबका? कैसे
Yes, sir.
करेंगे? यहाँ पे कितना है? 30 वोल्ट है. यहाँ पे कितना लॉस हुआ? 16. 30 में से 16 गया. हाँ मच यहाँ बचा, कितना बचा? यहाँ 14 बचा.
14 वोल्ट 14
14 वोल्ट हो गया. अब 14 वोल्ट हो गया यहाँ पर, तो इस ब्रांच में करंट कितना है? आई से
1.4
I10 हो.
एम्पियर.
Okay, so 1.14 divided by 10, that is 1.4 एम्पियर.
1.4.
टोटल यहाँ से 2 आ रहा था, 1.4 इधर चला गया, यहाँ पे कितना गया?
0.6.
0.6 एम्पियर. ओके, अब ये 14 वोल्ट है, माइनस 14, यहाँ पे कितना हो गया? 0.6 इंटू 2,
1.2
1.2, और
प्लस
ये
Vx.
प्लस वी एक्स, प्लस
Total
वी एक्स
zero.
0. तो वी एक्स कितना आ गया आपका? 14 माइनस 1.2,
12.
12.8 वोल्ट.
12.
ओके,
Yes,
so this should be clear to you. Okay, मैं और भी ज़्यादा कराना चाहता था लेकिन चलो कंप्लीट नहीं हो रहा. चलो एक क्वेश्चन करा देते हैं फाइनली, नए टॉपिक पे नहीं जाएंगे क्योंकि लेट हो गए हैं. तो सिमिलर ऐसा ही क्वेश्चन कर लेते हैं एक और, एंड देन विल स्टॉप द क्लास. ओके,
So, can you stop now because I have to go to Master and 9 p.m. is closing of mess.
ओके, ओके. सो जस्ट आई विल गिव यू होमवर्क. ओके, ओके, चलो चलो कल ही करेंगे. ठीक, कल ही करेंगे. ओके, स्टॉप. थैंक यू.
thank you.
Okay, thank you, sir. Thank you very much.